Okay, welcome to Chapter 5. Just as a reminder, we are going to use Visio, so if you don't already have that installed, now would be the time to do that. Okay, so Chapter 5 is all about data modeling. And up to now, what we've had is somebody gave us something like an Excel spreadsheet. We had to break it up using normalization. Well, here we have nothing. We're starting over from scratch, like you're building a brand new business, and you have no data at all. And so you need to talk to somebody about how they want it to be configured. So this is like a mental exercise. We're not actually building a database yet. We're building a model that contains the kinds of things they're going to be asking. For example, somebody said, well, this item is always in this warehouse. And so you come to them and say, when you said always, you mean it's not possible for this item to be in this second warehouse? And they go, no, that's not what I meant. See, it's a conversation tool. Okay, good. Let's continue. So, learning objectives, page 218. So, modeling versus design. Modeling is starting off from nothing. Design is actually building something. Okay. Understanding an entity relationship diagram, an ERD. This basically is the same thing we've seen in the Microsoft SQL Server Management Console. When you go in there and you ask for a database diagram. Okay, that kind of thing. Determining the minimum and maximum cardinality. Ooh, how's that for a good term? Cardinality. And understanding recursive relationships, where a table is related to itself. Okay, so let's just start. So introduction is, I'm building something from scratch that does not exist. I have no data whatsoever. I don't even have column names. I got nothing. And so somebody says, yeah, we're going to have an inventory. And you go, ooh, well, okay, I need this, this, and this. Then you show it to them and say, is this what you had in mind? Okay. So to start with, what you typically start with is a system development lifecycle, an SDLC. Before you start any project like this, doesn't matter what it is. If you're building a bridge or building a database, it doesn't matter. It all starts the same way. And that is, the first one is going to be like the investigation and planning phase. Basically, that phase is basically asking the question, what are we trying to do? What problem are we trying to solve? Because if you cannot describe the problem, then practically any solution will look just great. So you have to really be able to identify what the problem is or what the thing is you're trying to accomplish. If you don't know what your goal is, you don't know what direction to go in, going fast isn't going to help any, right? Okay, good. Then an analysis phase. Analysis phase means, okay, you've told me that you wanted a database that can be for e-commerce. Now I'm going to analyze that and tell you, maybe there's some commercial products out there. Somebody's already solved this problem. I don't have to deal with it. Or I can build my own, that kind of thing. And then the actual design where you get down and say, okay, now we're going to use Oracle and we're going to use this. Okay. And then implementation. Implementation typically includes building or buying. And it also typically includes like the initial training, inside that package is the initial training. And then maintenance. And maintenance is one of those things where it's ongoing forever. Like once you build this thing, you're going to have a help desk, and you're going to have people to get bug requests and, feature changes and things of that nature. So these other things are relatively short term, but maintenance tends to go on for years. Okay. So here's the problem. If you walk up to, you're building a boot repair business. And so I go up there and say, okay, what data do you need? They're going to go, hell, I don't know. So you're going to need to be able to coordinate with them and talk in a language that makes sense to them. Let me tell you a goofy story. Now, look, this is a goofy story, but I like this story. So 10 million years ago, we had an accounting system, and we were going to do an abrupt changeover. We were just going to drop it one day and pick up the new one the next day, with no overlap whatsoever. And it freaked out our budget people. They went, oh my goodness, I can't believe we're just going to have just an abrupt cutover with no way of checking to see if this thing actually works. So he came to me and said, could you write me a program? All I want to do is just randomly pick a day and gather all of the labor hours that were put into the new system so I can analyze it to see if it actually matches. And I went, okay, that's a pretty reasonable thing to do. So basically, I wrote a program that went through and gathered all of the labor hours for that day and printed it out on a printout. And so I said, okay, is this what you want? And the guy says, that's exactly what I want. Thank you. So I walk off. I come back, and he's got a bunch of yellow highlighters of different colors. He's going, I said, what are you doing? He goes, well, you know, we need to separate all these by the type, you know, the account code that each person charged their time against. And I said, well, why didn't you say that? And he goes, oh, well, can it do that? It's like, well, yeah. And so I went in and made a change to the application, so it's basically just sorted on the account code. So is this what you want? He goes, that's exactly what I want. I said, great. So I walk off. I come back a couple days later, and he's got this thing like on an old drafting table, and he's got a calculator. He's going, I go, what are you doing? He goes, well, you know, you sum up all these costs by this account code. I said, why didn't you say so? And he goes, oh, I didn't know we could do that. And it's like, okay. And so I made another change, and this went on and on and on. So the moral of the story is, some people absolutely cannot articulate their needs. They can't do it. It's a bridge too far. They don't know how to ask for things. And so you're going to have to be that step in between, that 1 foot in their world and 1 foot in the database world. That's what kind of makes you special, is you can live in 2 worlds at the same time. Okay. On page 219, they start talking about the purpose of doing a database model. I'll tell you, in my world, I think there's 2 purposes for doing a database model. The first one being, well, it's a well-established set of rules that you use to get the requirements. Yeah, okay, that sounds like a textbook answer. But that's not really all there is. The other is, it's a communications tool. I can walk up to a guy and say, okay, now, a single customer can have multiple orders. Is that right? And he goes, yeah. And this part is always in this warehouse. Always. And he goes, well, maybe not always. You go, oh, okay. So it's a communications tool, something you could point to on a piece of paper and say, okay, this is what you said, but is that exactly what you meant? Okay. So 2 parts. Sure, it's a well-established set of rules so that you don't forget anything. Okay, I'll give you that. But it's mostly a communications tool to help you bridge the gap between them not being able to articulate the requirements and you having to have the requirements to be able to get stuff done. Okay, so the model that we're talking about is like, we're going to do this in Visio in just a few minutes, but it's basically a piece of paper. Okay, there's no data involved, right? Right, it's just a model, okay, a blueprint, right? You know, when you buy a blueprint to have a house built, you know, all you get is a roll of paper, right? You don't get a house, you just get a roll of paper. You hand it to someone else, they build the house from that. Okay, that's what this is. It's a blueprint. And so it's going to have like the attributes, you know, like, you know, customer name and first name, and you probably are going to have to pick those attribute sizes. Like, for example, what is the size for the first name and the last name? And you're going to have some conversations with them. For example, part number, okay? Like in the federal government, they use a national stock number, and it's like this long. But maybe their part numbers are like this long, and they're numeric. You know, so you're going to have to say, hey, is all your part numbers going to be just plain old numbers? And, you know, numbers are letters or both? So you're going to have to ask some questions. And how big is that field going to be? And is it a number or is it an alpha? Okay, so they basically say that there's 3 parts to the modeling. A conceptual design. A conceptual design is just a starting model. That's basically for non-database folks to be able to understand what's going on. And so that's where we're starting off in Chapter 5, is this conceptual model. And then after you've got it a little bit firmer, you can go to what's called a logical design. And a logical design is almost complete. Almost. What it does not have is you have not picked the database at this point. In the logical design, you haven't picked that yet. And so you don't really have a real physical design ready to rock and roll. You just got something that's almost complete. It's like 90% complete. Okay. And then last, of course, is the physical design. And that's, you could kind of use this as a recipe or a set of instructions for how to actually build the database. Okay. And obviously you would have to have picked the database product like Oracle or SQL Server or MySQL or whatever. Okay. So on page 219, they start talking about this entity relationship and an entity relationship diagram. So here's one way of looking at an entity relationship diagram. So an entity, okay, remember I tell you they use different terms at different points. So instead of calling this a table, they call it an entity. Don't get hung up. It's not that big of a deal. So here's what they said they needed. So the customer entity has a customer. That's the kind of sort of what like I would call a primary key, but they don't make that distinction. And then a customer number, name, street, city, state, zip, contract. And so here's some examples. So examples, if you were using the other terminology, this would be a table and these would be rows. But instead, they're using entity and instances. Don't get hung up. This is not anything new. So customer number 1234, and he's Ajax Manufacturing. Okay. So an entity is typically a noun, a person, place, or thing. Typically, like a customer, right? I would caution you, even though I just said that the customer is actually a table, don't immediately go there, because quite frankly, we may have like a many-to-many relationship that in the model is going to look just gorgeous and everyone's going to be able to understand it. But behind the scenes, we're going to need an intersection table, which I don't want to show them because that would be too confusing. Okay, so there's not going to be a one-to-one relationship between the entities in the beginning model and the physical design tables. There probably will not be 100% the same. You may have 10 tables in the model and 15 tables in the honest-to-God database when you're done. Okay. So there's a thing called an entity class, which again is kind of a goofy thing. So here's an entity, and one way of doing it is showing it in ellipses, like every employee has an employee number and a name, etc. But most people do it in this technique using a rectangle. And that's the technique that we're going to use later on when we get to Visio. Okay, attributes. Attributes are those ovals or columns or the thing you see over here in the employee thing. So in this particular case, here's the employee. I'm going to go ahead and say table. And here is, I'm going to go ahead and say primary key. And then here's all the rest of the attributes. Okay. So clearly, these attributes are things that you want to store about the entity. What data do I need from a customer? What data do I need from an employee? And then obviously, later these are going to become columns in a table somewhere, but not just yet because we're just in the modeling stage. An identifier. Okay, so they call this, rather than jumping ahead to the physical model and calling it a primary key, of course, they're going to use yet another name just to annoy you. This is the identifier. It is the same thing as the primary key. Again, don't get wrapped around the axle here of using different terminology. Okay, that's why I said this was a primary key. But in the textbook, they're going to call this an identifier for a while. Okay, so then we have relationships on page 222. So relationship class, I know it's kind of dumb, but a relationship between tables could have a name. You could actually give a name to, a customer, okay, an employee relationship to a department, okay? One department has multiple employees, but most likely a single employee won't have multiple departments. So there's a one-to-many relationship there, and you can actually give it a name. So there's some terms here that you're going to have to learn, and these are kind of funky terms, so again, just bear with me. The first one's called degree, and degree is the number of tables that are participating in the relationship. That's it. It's not complicated. So if I have an employee table, that's 1, and a department table, that's 2, I have degree of 2. Okay, that's simple. Hey, we're coming up on the 15-minute mark. You guys know how this works.